Hello good people, I'm going to continue talking about the valence shell electron pair repulsion model. Seeing how my artistic talents are very limited, I'm going to use this software created by the good people at the University of Colorado Boulder. This software will allow me to better demonstrate the three-dimensional shapes of the electron geometries. This purple sphere represents the central atom of a small molecule. At this stage, we are not so much concerned about the identity of the atom or the identity of the molecule. We just want to see what happens to the electron geometry as we add electron pairs. Alright, so let me add the first pair of electrons. The software allows me to move my atom around, to rotate it, and to hopefully demonstrate that this molecule, or this atom right now, exists in three-dimensional space. I am now going to add a second pair of electrons. What has happened? Well, if I rotate the molecule, the atom around, I can see that the electron pairs are now 180 degrees apart. They have arranged themselves so that they are as far from each other as possible. Let me add a third electron pair. What do we have now? Well, once again, the electron pairs have arranged themselves to be as far apart from each other as possible. And the resulting electron geometry is trigonal planar. I'm going to add a fourth pair. Alright, what do we have now? Well, again, the electrons are arranging themselves in such a way to be as far apart from each other as possible. The resulting electron geometry is tetrahedral. I'm now going to add a fifth pair of electrons. And here it is. If I rotate this molecule around, I can again see that the electron pairs are arranging themselves so as to be as far apart from each other as possible. These two electron pairs, above and below, are the axial electrons, and the ones arranged around the atom are known as the equatorial atoms. Pardon me, not atoms, electrons. So once again, these two electron pairs above and below are the axial electrons, while the electrons around the atom are known as the equatorial electron pairs. This shape is trigonal bipyramidal. I'm going to add another electron pair. Now I have 6 electron pairs arranged around the central atom. And, at the risk of repeating myself, the electron pairs have arranged themselves so as to be as far apart from each other as possible. This electron geometry is known as octahedral. I'm going to summarize this by going backwards. Currently, I have 6 pairs of electrons and I have an octahedral electron geometry. If I remove one, I have 5 pairs of electrons and a trigonal bipyramidal geometry. If I remove another pair, I am left with 4 electron pairs, and now I have a tetrahedral geometry. Going down to 3 will give me trigonal planar or trigonal planar geometry, and going down to 2 will give me a linear geometry. That is all for now, and I will see you on the flip side.